Yeah, awesome. Welcome, Sebastian. How you doing?
Hey there, pretty good.
Oh, good. So you and I know each other from the conference scene. We bumped each other many times along the way, don't we? So I won't take up too much of your time, Sebastian.
Sorry?
I won't take up too much of your time. If you wouldn't mind sharing your screen, Sebastian, we'll just
Absolutely. So,
fire that up. It's roughly 25 minutes for the talk, and then I'll keep a lookout for questions too. If folks have got questions, jump along the Slack, pop the questions in there. I'll queue them up for Sebastian at the end. I'll give you a 5-minute warning, Sebastian. You can ignore me. Feel free to. Let me just share your screen.
screen right now? Perfect.
Looks good. I'll disappear off, Sebastian. Away to you. Thank you very much.
Awesome. Yeah, thanks a lot. And welcome as well from my side for the session on cloud native Java for this decade with Quarkus and what that Quarkus is about. So yeah, I want to jump right in because we don't have too much time. So my name is Sebastian. I do some stuff with Java, and I want to introduce some Quarkus for you. And we have a little bit of live code, actually, or mostly live code, and a little bit of talking, let's put it that way, and why that is the modern way how to build cloud native Java for the cloud, for containerized workloads. So it's called supersonic subatomic Java, and there's a few things to it. Especially there is some build time optimization going on, which really makes sense in terms of how to build applications. But actually, I mostly want to show you some code. So I have a project that is called a coffee shop project here because I like coffee. And that is using Quarkus in the version 1.3.2. I think that just has been out now. And just because I'm brave enough, I use Java 14. So you should all upgrade. That's the latest version until a few months from now. So we're moving really quickly. And in this project, I just want to show you some things that you might be familiar with if you know enterprise Java from the past. And that is actually one of the interesting takeaways of Quarkus, that we can use a lot of known APIs. It does not reinvent the wheel all over again, but it just has some pragmatic extensions or additions, if you want, that really make sense. So for example, what I want to start with is an HTTP resource. So we have some REST going on with some coffee orders. I didn't want to live code all of that just because to get into the interesting details. And what that is, it is a resource here where we can just read, create, read, update, delete some coffee orders here. And it already includes some stuff here. So let me just run this. We could build this application. I use Maven, using Maven package, and we will see it builds fairly quickly. I say fairly because it does much more than just compiling. It has a Quarkus plugin, and it says builds, and it does some optimization that basically does some what is called tree shaking for your application to only include the stuff that you need when you run. So this is already quite interesting. But actually what I want to show you, just because it's faster, is this Quarkus development mode, Quarkus :dev. And this is really interesting for us because it starts up our application in a mode where we can just change some code and then watch the changes being reflected. In this case, in a local process. So what it does, I can fire up localhost 8080, and now it's already running. There's no resource here because my resource is called orders. Or actually, what we can have a look at first is a health check resource that's also there. That also uses MicroProfile health, if you're familiar with that. So again, a known API where it doesn't reinvent the wheel. I can quickly show you that. So this uses just some MicroProfile code. And again, if you're familiar with that API, you don't have to learn new stuff. You just apply it. Things that are also available in other enterprise runtimes already. So I think that's a pretty cool solution to be a little bit pragmatic. But what I want to do now is to get some coffee, right? So I can query my coffee order. Let's make this bigger. And as you can see, that is an empty JSON array. There's no order in the system. So if you have a look into the resource, what's going on, it basically is calling this method, HTTP GET method, in my JAX-RS resource. And then it includes something that is called JSON-P, JSON for programmatic API creation. And I have a JSON array that I can just create here using Java 8 streams and lambdas and things like that, just to build some coffee order. let's also have a look into our order actually. So that's going to be our main domain object, what that is, because we want to create an order in a second. And an order contains some, like identifier, some type, which is an enum, depending on what we would like to order, things like that. And some status, what's the status of our order. And as you can see, that is going to be returned in this JSON P format. But also, when we want to create an order, we can map this into our REST resource. And here you can also see, well, if you're familiar with that, that is actually bean validation, also Java standard, that is included. That works with plain JAX-RS, as always, if you're familiar with that. And this also uses the JSON-B binding here, where I already have some annotations that just modify how that's going to be bound to my Java objects. So that is just, the nice story to be able to code with some more ease. When I just want to invoke this, then it already tells me 400 bad request. Why? Because I need to set the type. So that's good news. It integrates with this validation already. And I, of course, need to set, well, I want to order, let's say, some espresso, right? And now this order is in our system, and I can go and hit that URL. And then I can return just a single order that we saw it in the code was mapped by JSON-B. So I think that's already pretty cool to start with. But now, of course, we want to do a little bit more with it and change some code. So what I have here, I have that is a CDI bean, application scope bean, that actually just stores my coffee orders here in a concurrent hash map in memory, which is obviously not the best idea if I want to have multiple applications in my cloud setting, or if I just want to start and stop and start up again. So what I want to include just for some live coding is a database. And now it's already getting a little bit interesting if we do some local development, like how to run, like some database setup in the most efficient way. There have been tons of solutions out there, where not all of them may be super efficient. And nowadays, it's a really good idea to run stuff in Docker containers also when developing locally. So this is what I'm actually mostly doing. My app here right now is just running in a process, started with Maven. But actually what I want to just run a database where I have some script already. So just stop my application again, and I run a database that runs up my Postgres database. So assuming that is the database that I want to have for some local development that I could already fill with some entries, with some tables, and so on and so forth. And now actually I want to go and take my coffee order to, have some persistence. And that is where it's already quite interesting what Quarkus does. So if you have a look into the guides, that is probably the best starting point to not only getting started, but also if you're already familiar, how to do things. This is, I think, a very good documentation how to do things. And then you will find a guide how to do persistence and how to use, JPA, this API that you might be familiar with, and also using a thing that is probably new to you that's called Panache. Like a framework that just gives you a little bit easier access, a little bit similar, a few ideas what Spring Data can do. And what I want to do now, I want to include this into my coffee order while my application is running. So first of all, I need to configure the database. So I have my application.properties, which is also not a standard, but I think a very pragmatic way how to configure your app. And I say, well, please set up a persistence for, I call this coffee shop DB. That's going to be my database. And now these are just some properties, local host, that I can set, the driver and all this access and so on. And that is the URL in my containerized environment. And the same is true for a Kubernetes environment, thanks to services and external services and all these things. I can use a hostname resolution to just say, oh, just point it to coffee shop DB, wherever that is. And then the DNS resolution will just point it to the actual instance. The same is true locally. If you use a Docker with Docker networks or Docker Compose, you can just use the container name or a service name, and that works really well. If you want to have a different setup, and that's already, the harder things to configure, With the development mode, you can use this, it's called profile, like a meter or some pseudo setting for a local host to say, okay, if you run locally, then actually I need to access my container, my database differently with that locally published port, right? So this is why I run the local host here. All right. And then in this case, now I want to add some persistence, right? So if we're familiar with JPA, we know, well, this is probably supposed to be an entity, and it's going to be let's give it a nice table name like orders, right? If I can type, I didn't get my coffee, as you can see, orders, perfect. And now what I could do, well, I could use all of these annotations and getters and setters that I'm used to, but actually what I will do differently now, and you can see this in the guides, that is a somewhat best practice or an approach to say, now please don't throw something against your screen. As a Java developer, this is a little bit unnatural to us to say, okay, we actually make these fields public. And I will extend this class for a panache entity, or in my case, an entity base. The difference is the base doesn't define an ID because I actually want to have my own ID definition. My UUID should be the ID, and that should be a generated value. And then all of the other fields are going to be serialized, and that's it. So that's all I need in order to have a persistent entity with panache. So which I think is pretty cool, because now what we can do, I think I need to start my application, and I hope that already works. Now what we can do, we of course get some compile errors. That doesn't matter. I can just continue coding and use this a live reload approach. So first of all, I can get rid of my map where I stored my orders, and now I can say, okay, actually, and this looks a little bit weird in the beginning, use coffee order, now the class, with a static method dot find all or list all. Just list all orders. That's it. And then it will do basically the same thing like you would do using an entity manager to find all of the coffee orders and so on and so forth. You can further order them, you can sort them, or you can have some extra queries if you want to extend this. To get the order, same coffee order, find by ID, and that's the ID, and that's it. So in the past, there was a pattern called active records, which is a little bit similar, I would say. At first, I wasn't quite sure what to think of this approach, to be honest, and I wasn't quite sure whether I like it. It also depends on your hierarchy in your domain model, whether you'll be able to, for example, extend a class and all these things. Good news is you can always roll back to a normal JPA approach. So you can have getters and setters where with the annotations. You can have just a normal JPA entity. You don't need to extend anything. There's even something called Panache repository, which is, I think, very similar to Spring data repositories, which is also a very cool approach. But this is even less code. So if it can go with that approach, I think it does make sense. And then coffee order, same for persist. We can just persist an order. In this case, the persist doesn't return anything. So we can say, okay, now the order ID should be set. So in this case, I just want to return the order because we actually need this in our repository. And that's pretty much it. So I think that's a nice approach just to do persistent. Now, of course, all of these getters don't exist anymore. So let me just quickly fix that. This including the ID, because we just removed all of them. And then actually, I think the first approach failed because it didn't compile. And then we can just restart our application and try this approach with our persistence now. And again, I think that's just a nice way to integrate this very cleanly. And that's one of the reasons what I like about Quarkus. It's very pragmatic. So it allows you to do a lot of stuff just easier. You probably also know this, there is no JAX-RS application, so we don't need to subclass what we always did with this JAX-RS configuration. If not, then just it assumes / the root resource, which is true for us. And now let's do the curl again. So this should be up and running again. Yes, and then I say orders, which now is empty, because now actually the database is empty. But now if I create a new order like an espresso, okay, transaction is not active. Yes, one thing I of course forgot. It's not your fault. You cannot shout at the stream, but I need to make that transactional because probably, as you know, a CDI bean is not transactional per default, unlike a EJB bean in the past. And we have to make all of these methods transactional now, or just the class transactional. And then let's see. Now this will, and now you see the feature of the hot reload approach. It would just reload your application, and then let's make this again and just display my orders. Now my orders are in the system. That's good news. And now let me just be brave and stop and restart my application. I now hope if I did everything correctly, it doesn't kill my tables, but leave them in the database, and then it should just after it has been started up show my orders again. You can of course set up the properties here, what you're probably familiar with from Hibernate, and then now my orders are in the system again, and I can use that approach. So that's just one of many things that I wanted to show you, where I think it's kind of cool to include persistence in such an easy way as compared to the past in an enterprise app, where actually what I need to configure are these two dependencies, ORM Panache dependency, and then of course my driver, in my case Postgres, and then these properties that I set up. So this works with that approach, and then well, we can run this as you can see. Now a little bit more to the cloud native side of things, and what that is. So you probably would run your application in Docker containers. So now actually at first I only run my process locally, but what I can do, of course, I can run things in Docker containers. And now a few things. So that is my Docker file that I use, and I almost always actually use Quarkus in the JVM mode. So you probably might, connect in your head Quarkus with running applications natively, which definitely is one of the big benefits that you can do with Quarkus, that you can actually compile it down to a native executable image with GraalVM and Substrate. But I actually think it makes a lot of sense to just run it in plain JVM mode for a bunch of reasons. So first of all, if your ops team, for example, is used to run things in a specific JVM, Hotspot or any other JVM of your choice, then it's the same thing. You just run yet another app, yet another executable jar on that JVM, and you get a big improvement in resource consumption and startup time already in plain JVM mode. Why? Because the biggest benefit of let me just make clean package for now to clean and build this again. The biggest benefit of what Quarkus does is the build time optimization. So what it does, it takes all of these dependencies, all of these inversions of control that we have, and basically resolves them at build time. And you already get, direct code, direct invocation. So there's no reflection, there's no inversion of control going on where you just have to manually grab all of your beans together. No, they're already there. You know what you use, and it just starts. And this is why it starts up that quickly, even in JVM mode. And only that allows you to compile it down to native if you want, using GraalVM. And that makes it, even faster and better. But another reason, what I always advocate for basically Docker images is trying to separate your application from the runtime. So making use of this Docker layer approach and of the caches of this layered file system. So what you have here is this Docker file where I just built my application, and if I say Docker build, temp, and that just builds up my app, and this runs very quickly because only in the beginning it adds all of my dependencies, and then what it does, it just adds my app, which you can see is pretty tiny. It's just kilobytes, and actually the rest is the remaining things are contained in this lib folder, and the Docker file maintains that. Well, the JVM version Docker file. So with the native image, you still have everything in an image, which is comparably small. But then if you do Docker push and pull, you always have to, basically ship and push and pull everything, or at least that big layer, and not just your thin layer application. So I think that does make a difference here. Let me see. Okay, that is still running. Let me run this application. No, that's run port 8080, and actually for my local setup, I need a network. That is just my setup here, because then it wants to connect to the database. And now this error just says, well, the table already exists. So that's just a warning. And now I can say, okay, localhost 8080, perfect. Orders, and there are my coffee orders again. Now, this is my Quarkus application that runs in a Docker container locally. So that is now my locally running Quarkus app in a container. So both this and the database now running in a container. And then I can basically use that also for local development and, well, further deploy it. Speaking of which, let's have a look into Kubernetes. Just very quickly, I want to deploy this app now to a Kubernetes setup. I have a Kubernetes cluster in the cloud, a managed cluster in the IBM cloud here. You can equally well set up anything, that is Kubernetes. You can have a mini cube on your local laptop. You can have mini shift for OpenShift cluster. You can have an managed OpenShift somewhere that's also Kubernetes, whatever you would like to have. So I have a Kubernetes cluster right here that I just created actually before, and which now it should be empty. Yes, so there is nothing running. And now what I can do, I just want to deploy that using, well, some YAML, of course. There are actually other ways to do this with Quarkus. So there are some Quarkus extensions and plugin where I can say, okay, you can actually write something where you don't even, where you're not even required to write a Docker file or to write these YAML files. I actually like to do it this way, where I have, the control of these files. That's a little bit a question which approach you want to take. Also, usually in your DevOps approach, you need some more control over what you're doing within your team. So this is just if you're familiar with Kubernetes, of course, the Kubernetes service, some deployment where I just deploy all of that stuff. Then I'm also actually running an Istio cluster here. So I have this Istio gateway and, of course, a virtual service, destination rule, and all these things. I think the Kubernetes and Istio project does a good job at documenting that, if you're wondering what all of that is. But now we don't care. We just apply it, throw it against our cluster, and then it creates a bunch of stuff here. And one thing that is already pretty cool, it just starts up very quickly. As you saw, I mean, the app starts up very quickly. So now it's already up and running and ready. We don't have to wait for anything. And I can already curl and query my app. Let me run my magic script that gets me the IP address of my cluster. And then I say, well, just orders. And I see now my coffee orders, or I can have a look at this health check. And now I see, well, my application.
Sorry, Sebastian, we have lost your screen there, mate. Sorry to interrupt.
Yeah, no, thanks for letting me know. That's actually a good point. I don't know what just happened. Okay, let me just try to restart.
No worries.
Using my, it's actually a very interesting setup that I have here, using a second computer, and that grabs both of this camera and the screen, and was actually supposed to. Now let me do this again, which is funny because it happened many times that it started that it crashed before starting, but it never happened that it's basically crashed while.
Oh no!
Re-unplug this again. So sorry for that. Okay. Let's see. If not, then I just talk it through. I can talk a lot on these slides. So
you've got about 7 minutes left, Sebastian, so no pressure.
Let me just do one more thing I'll just quickly stop sharing, because then I'll try to reconnect that. Just actually, this should be the setup. So now you can see me full screen, and I'm just trying to restart. It uses OBS under the hood, which is actually a very interesting approach if you're ever wondering, how to do all of these live streams and stuff. So that's a very powerful approach, I would say. Where if you've seen other videos that I did, where I can do some.
They do look cool. Yeah, I'm liking this. Your video skills are very good.
Exactly. Oh yeah, there we go. Now
we're good.
Back up again. Let me just quickly make this differently. That you see me full screen like this, and I'll just trying to share the other screen again. Nope. Oh, wait a second. That was oh yeah. Share screen. Yeah, that's it.
Just got to give a shout out to Naveen for nudging me on this one, and Andy as well. They mentioned they missed the Kubernetes stuff.
Yes, now you should be able to see some nice YAML again.
I'll disappear. Thanks, Sebastian. Good stuff.
Perfect. Yeah, thanks for letting me know. All right, so now actually we have this up and running in Kubernetes. So that was, I would say, quite easy, fairly easy and quite quick to do. And also a big enabler is just that we have this hot reload mode, and just the fact that Quarkus starts up so quickly. I have a bunch of resources for you that you might have a look at. So that's actually a longer post that I wrote. This is something that I found interesting as well, how to run a different JVM actually with Quarkus. So I show how to do OpenJ9, and if I in this video, and if you paid attention, that's actually what I'm running here as well. And in this video, I'm doing some comparison. Like if you do nothing else than just swapping the base image, you already save a lot of resource consumption. Like you save a lot of memory yourself. Especially interesting if you actually want to run Quarkus in JVM mode in production. And another thing is that's quite interesting is that you can run this colon dev mode that we all really like, because it's just so efficient to use. You can run this in containers also. There's a thing called Quarkus remote dev for a remote dev approach. And in this video, I just showing you how to build this up. It's not quite straightforward. You have to, do some things like write another Docker file that includes Maven and Quarkus and these things. So I show you this, how to get started, and then it might be a little bit easier. Other than that, some key takeaways. So I think Quarkus is a very interesting and modern approach how to do cloud native Java, and especially that it builds upon existing and known APIs, right? You probably have used CDI in the past, JAX-RS, JPA, and all these things. You don't have to reinvent the wheel, which really makes sense. The point that it cares about the developer experience as well. You saw this approach of the hard reload approach. You probably have seen videos in the past, so I didn't spend too much time on it, but you saw me coding and then just reloading immediately. And that just really makes sense, because we humans just easily get distracted, right? If I have to wait just 10 seconds for something to start up, you might say, well, it's not a big difference. Actually, it is. Because if I have to wait 1 second, then I just wait for it, right? But if I have to wait 10 seconds, well, I'll check my smartphone, I will look into Slack, check the emails, and then I'm distracted, and then I'm gone, right? So we need to have that immediate feedback to stay in that flow. I think it's especially interesting if you already have some investment in EE, means your developers are known to these APIs, or you actually have some EE apps. And it's actually quite straightforward from my experience to migrate those to Quarkus, because, a known code, known APIs, and then you have to change the runtime only. And you can go native with that, which is, I think, a very cool feature to really save resource consumption, and actually a big enabler for cloud offerings to basically save yourself a lot of money. Because if you run the same runtime with now, a small fraction of the resource consumption, you either can scale up much easier, or you just save a lot of money by scaling down your cloud resources. I probably shouldn't say that because I work for a cloud provider, but it's really good for if you run your offerings there in this approach. And if you want to get started, Quarkus, guys, definitely your friend. I will share some more resources, but that's a good way to document that and basically to get started with that. And then actually, I want to open it up for questions. Thanks a lot already for your attention. If you follow the first link there, you will get to a page that shows you some additional resources and some videos that I created. And I hope that is interesting for you.
Super stuff, Sebastian. Really enjoyable there, and well recovered on that issue. That's never fun recovering live. Yeah. We've got time for one question. I think it's a quick one, if that's all right, because we've only got like a minute or two left. Andy Muir mentioned about a live reload is cool. However, for a BDD/TDD approach, what does it bring to the table? Because really, I'm writing my test first, then I'm coding.
Yes. Oh, actually a lot. So that's a very good question. In general, besides TDD, if you have something that you can test locally, where you have, code level tests, where you don't even start your app, well, then there's no difference. You just, run your tests in your IDE, and you can just very quickly test your business logic and rerun, your unit tests or JUnit or whatever you have. But I think it is actually a huge enabler if you want to test more end-to-end approaches like system tests locally, where you say you start up your app, you start up your database, the backend that you have, and then you fire your system tests against your application directly. And this approach allows you to program really with high efficiency, because you don't have to wait, right? You change your application, and it just quickly changes. You rerun your test, it already connects against it, and it's already there to change. So, then your test breaks. Okay, now you have to update your tests, or the other way around, but you can very quickly get that feedback. So I think it does enable you a lot, especially if you do your testing approach on a more end-to-end perspective locally.
Great answer, Sebastian. I reckon this is a good topic for the Slack channel as well. I reckon Andy will have some follow-up questions there. I like your pitch back. Again, thanks once again. We're going to go for a 10-minute break now, if that's all right for everyone. But yeah, join me in thanking Sebastian on the Slack.
Thank you.
See you again soon.